Welcome to our channel, Explorers of the Cosmos. Today we're embarking on a thrilling journey to unravel some of the most mind-boggling planetary mysteries that keep astronomers up at night. Get ready to have your mind blown as we delve into the heart of these cosmic enigmas, from planets with gravity so weak that their atmospheres bleed into the void of space to celestial behemoths where time itself bends to their will. Fasten your seatbelts, because we're about to launch into a cosmic adventure that will reshape your understanding of the universe and our place within it. Let's get started. Picture this, a planet so small with gravity so feeble that its atmosphere, the very breath of its existence, slowly escapes into the cold vacuum of space. Sounds like a scene from a science fiction thriller, right? Well, in the vast expanse of the cosmos, truth is often stranger than fiction. You see, gravity is the cosmic glue that holds everything together, from the largest stars to the tiniest particles. It's what keeps our feet firmly planted on Earth and what prevents our atmosphere from drifting off into the void. But the strength of gravity depends on mass. The more massive an object, the stronger its gravitational pull. Now imagine a planet significantly smaller than our own, say the size of Mars or even smaller. These celestial lightweights have weaker gravitational fields, making it harder for them to hold on to their atmospheres. It's like trying to hold on to a handful of sand on a windy day. Some of it is bound to escape. As these planets orbit their stars, constantly bombarded by solar winds and radiation, their atmospheres are stripped away, molecule by molecule, over millions and billions of years. This process, known as atmospheric escape, can transform a once vibrant and potentially habitable world into a barren and desolate wasteland. Think of Mars as a stark example. Once it's believed to have possessed a thicker atmosphere and possibly even liquid water on its surface. But over eons, Mars, with its weaker gravity, lost much of its atmosphere to space, leaving behind the cold, thin, and arid environment we observe today. Atmospheric escape could be the difference between a world teeming with life and one locked in a perpetual cosmic winter. So, the next time you look up at the night sky, remember those unseen planets, some perhaps losing their grip on their atmospheres, slowly fading into cosmic obscurity. Time, the seemingly relentless and unchanging backdrop of our lives. We mark its passage in seconds, minutes, hours, but what if I told you that time itself can be stretched and squeezed, warped and distorted by the very fabric of the cosmos? Welcome to the mind-bending world of time dilation, a phenomenon predicted by Einstein's theory of relativity, where time is not absolute but relative to the observer's motion and the strength of the gravitational field they experience. Imagine a pair of perfectly synchronized clocks. Now place one clock on the surface of a massive planet, a world significantly denser and more massive than our own. Leave the other clock here on Earth. What happens? According to Einstein, time slows down in stronger gravitational fields. So, the clock on the surface of that massive planet would actually tick slower compared to the clock on Earth. It's not that the clocks are malfunctioning, it's that time itself is flowing at a different rate in those two locations. The difference might seem minuscule, fractions of a second perhaps, but it's a real phenomenon, experimentally verified here on Earth using atomic clocks. And the more massive the object, the more pronounced the effect of time dilation. Now, let's take this cosmic thought experiment a step further. Imagine a planet orbiting a black hole, an object of unimaginable density and gravity so intense that not even light can escape its grasp. Here, time dilation reaches its most extreme. On a planet near the event horizon of a black hole, the point of no return, time would slow down to a crawl compared to time on Earth. Years on that planet could be equivalent to centuries or even millennia back home. But time dilation isn't limited to the vicinity of black holes. The faster an object moves, the slower time passes for it relative to a stationary observer. Time dilation might seem like a bizarre and abstract concept confined to the realms of science fiction, but it has real-world implications. For instance, the GPS satellites that guide us need to account for time dilation effects due to their motion and the Earth's gravitational field to function accurately. When we picture a planet, most of us envision a solid rocky world, much like our own Earth, a place with mountains, valleys, and maybe even oceans. But the universe, in its infinite creativity, has other plans. Out there, amidst the stars, exist planets that defy our Earth-centric expectations, Worlds without a solid surface, celestial bodies composed almost entirely of swirling gases. These enigmatic giants, known as gas giants, are planets on a scale that dwarfs our own world. Jupiter, the largest planet in our solar system, is a prime example. With a diameter over 11 times that of Earth, Jupiter is so vast that over 1,300 Earths could fit inside it. And yet, this colossal world has no solid surface to speak of. Instead, Jupiter is a swirling ball of hydrogen and helium, the two most abundant elements in the universe. As you descend into Jupiter's atmosphere, the pressure and temperature increase dramatically, transitioning from a gaseous state to a strange metallic form of hydrogen, a state of matter rarely found on Earth. Deeper still, scientists speculate that Jupiter might harbor a small rocky core, perhaps several times the mass of Earth. But even this core would be under such immense pressure that it would bear little resemblance to the solid ground we're familiar with. Saturn, the ring jewel of our solar system, is another example of a gas giant. While smaller than Jupiter, Saturn is no less impressive. Its iconic rings, composed of countless particles of ice and rock, are a testament to the planet's immense gravitational pull. But beneath those magnificent rings lies a world shrouded in mystery. Like Jupiter, Saturn is predominantly composed of hydrogen and helium, with an atmosphere whipped by powerful winds and adorned with colossal storms that dwarf anything seen on Earth. But gas giants aren't limited to our solar system. Astronomers have discovered thousands of exoplanets, planets orbiting other stars, and many of these distant worlds are gas giants, some even larger and more massive than Jupiter. The existence of gas giants challenges our notions of what a planet can be. They're worlds without a solid surface, places where the familiar concepts of land and sea cease to exist. Deep within the heart of our planet, a molten iron core spins and churns, generating a powerful invisible force field that envelops our world. Earth's magnetic field. This protective shield, extending far out into space, acts as a cosmic guardian, deflecting harmful radiation from the sun and cosmic rays from deep space, making our planet a habitable oasis in the vastness of the cosmos. But Earth's magnetic field also plays another crucial role, one that might surprise you. It acts as a celestial shield, deflecting potentially hazardous asteroids and comets that might otherwise collide with our planet, causing catastrophic damage. Imagine an asteroid, a chunk of rock and ice left over from the early solar system, hurtling through space at thousands of kilometers per hour, on a collision course with Earth. As it enters Earth's magnetic field, the asteroid encounters a force, a push that alters its trajectory, nudging it slightly off course. This seemingly small deflection over millions of kilometers can be enough to cause the asteroid to miss Earth entirely, averting a potentially catastrophic impact. It's like a cosmic game of billiards, where Earth's magnetic field acts as the bumper, deflecting incoming celestial threats. But not all planets are created equal when it comes to magnetic fields. Some planets, like Mars, have lost their global magnetic fields, leaving their surfaces exposed to the full brunt of the solar wind and cosmic radiation. Others, like Jupiter, possess magnetic fields so powerful they dwarf Earth's by orders of magnitude. Imagine a planet with a magnetic field so strong that it could deflect not just small asteroids but even massive comets, objects kilometers across, capable of causing global devastation. Such a planet would be a fortress, a cosmic sanctuary shielded from the cosmic bombardment that constantly reshapes our solar system. Scientists believe that strong magnetic fields are generated by the motion of electrically conducting fluids, such as molten iron within a planet's core. The faster the core spins and the more conductive the fluid, the stronger the magnetic field. So, a planet with a rapidly rotating molten iron core, perhaps larger and more active than Earth's, could generate a magnetic field powerful enough to deflect even the most massive celestial projectiles. But the search for planets with strong magnetic fields is about more than just finding cosmic fortresses. It's about understanding the conditions necessary for life to arise and thrive. Thanks for joining me on this incredible journey through some of the universe's most mind-boggling planetary mysteries. We've explored planets with leaky atmospheres, worlds where time flows differently, gas giants without a solid surface, and planets with magnetic fields so strong they could deflect asteroids. But our exploration of the cosmos is far from over. There are countless more mysteries out there waiting to be unraveled, countless more wonders to ignite our curiosity and push the boundaries of human understanding. Until next time, cosmic explorers.